All right, 1.2, part 2, solving linear equations. So we're still solving linear equations. It's just we broke up 1.2 into 2 sections. So here's the vocab. I believe this is now on your note taker. I know it was accidentally on the other part 1. So solution of equation, a value or values that make the equation true. Remember that means that it's correct, it's the answer. And then a variable, a symbol used to represent the quantity that can change. If you need a minute to write these down, push pause. So today we're dealing with fractions and decimals. We like to break those up. So the last one was integers, now we're dealing with fractions and decimals. So when we have a fractional equation, the best thing to do is to remove the fractions, and it has to do with the common denominator. So we still use the common denominator, but what we don't do is change the fractions to the common denominator. It's the easiest way. So the common denominator between 3 and 5 is 15. So I'm going to multiply the entire equation, including the equal sign, by what I say 15 over 1, right? It's a fraction, so this needs to be a fraction. I'm also going to put 5 over 1 so that they're all in fraction form. So we are going to distribute 15 through the entire equation. So 15 times 2 gets me 30, and 1 times 3 gets me 3, and that's 3y. Then I do 15 times, make sure you see that it's negative 2, so minus 30 over 1 times 5 is 5, and then we do 15 times 5, that's 75, and then 1 times 1 is 1. Once we do that, we can then reduce. So 30 divided by 3 is 10y, minus 30 divided by 5 is 6, and 75 divided by 1 is 75. So that's why we do that. See how much nicer that is? So now we solve this like a two-step inverse operations. We always do the adding and subtracting first. So I'm going to add 6. 10y equals 81, divide by 10, and I'm just going to leave it as y equals 81 over 10. All right, so here's another fractional one. Maybe pause, see if you can change it to the common denominator, or not change it to, find the common denominator and get rid of those fractions, and then unpause and see if you were able to do it. And then we'll do the problem together. So the common denominator of 6, 3, and 9, and technically 1, oh, and 1 here, don't forget that one, is 18. Because 6 times 3 is 18, 9 times 2 is 18, and 1 times 18 is 18. So we're going to take the whole thing and multiply by 18 over 1. So you can distribute all of them, don't forget the 2, and then divide. You can also actually technically divide. 18 divided by 6 is 3, and then 3 times 5 is 15x. So see how I did it in one step? You can kind of decide how you want to do it. 18 divided by 3 is 6, times 1 will get me 6. Then I still have to do the 2. Do not forget this 2. And 18 times 2 will get me 36, and then it's just over 1. 18 divided by 9 is 2, and then 2 times x is 2x. And then 18 times 1 is just 18. So hopefully you got the same thing. So now we combine like terms. All right, my variables, my constants, didn't mean to pick the exact same color. So 15x's, take away 2x's is 13x's. And then we have 6 and negative 36, so we get negative 30. You could also write minus 30, and then it equals 18. So the opposite inverse of this is just to add 30, because that's going to cancel that. If you wrote subtract 30, right, it'll show up a little bit better. That's why it's add 30. So then I get 13x equals, and this is 46. 8. And then I divide by 13. And our final answer, x equals 48 over 13. Okay? You can always pause and go back to see if there's questions. All right. So now decimals. So decimals you can do in 2 ways. You can just do the problem with the decimals, but there is an easier way, which is to remove the decimals based off of the largest decimal value. So this is at hundredths, this is at tenths, and this is at tenths. The largest decimal value is at hundredths, so we would multiply the whole thing by 100, and it will get rid of my decimal. What I'll do is I'll just move my decimal over that many times, so twice, right? Hundreds twice. So we get 12x. I'm going to move this over twice, 110, and I move this over twice and get 250. You do not have to remove the decimals, it just gets rid of them and you don't have to worry about dividing by a decimal or moving the decimal around later. And then you would just treat it like a 2-step. So plus 110 and 12x equals, right, 360. Divide by 12, we get x equals 30. All right, 12 into 36 is 3, and then we add our 0. So that's the way to get rid of the decimals in case you do not want to have to deal with the decimals later on. You do not have to do it that way. It just can make it a little simpler. So same for this one. You can either distribute first or you can get rid of the decimals. It's going to really depend on how you want to do it. Go ahead and pause. Let's have you do this, see how it goes, and then watch the process of how I decide to do it. But it's really up to you and how you want to do it. I would just like to distribute first, get rid of that parentheses situation. So 200ths x take away 600ths x, right? I'm just going to multiply by 3. Plus 1 and 400ths equals 102. So I'm going to times this whole thing by 100. Sorry, I'm questioning the 102. Seems like a very large number to have with these decimals, but we'll go with it. So I move this one twice. I get 2x minus 6 plus 104 equals, the decimals back here, 10,200. So I'm going to first combine these like terms. So I'm going to get 2x plus 98 equals 10,200. Then we're going to subtract that 98 from both sides, because the inverse of adding is subtracting. All right, minus 98 minus 98. So 2x equals 10,102. And then we'll divide by 2. And x will equal 55051. All right, so here's your independent practice. You need to complete these with work, all the above, showing your steps, showing what you multiplied by, if you multiplied, and it needs to be completed for credit in class. Until next time.